Okay, now we're going to move on. Instead of talking about series of numbers, we're going to be talking about series involving variables. These are called power series. So we will still be using a lot of the things we've learned about other plain number series, but now in a different context. So for example, let's say I have this series, the sum from n equals 0 to infinity of x to the n over 3 to the n, right? So if n equals 0, that's something to the 0th is 1, so 1 plus x over 3, when n equals 1, when n equals 2 you get x squared over 9, and so on. And this goes on forever, so it's sort of like a polynomial, right? I've got powers of x times numbers all added up, but it's an infinite polynomial. It just keeps going with bigger and bigger powers of x. This is called a power series, and we'll talk about that in a minute. The thing, though, is I can put in different values of x, and each different value of x I put in there will produce a different series. So if I substitute in x equals 0, I get 1 plus 0 plus 0 plus 0 plus 0 forever. That's a pretty boring series. We can tell it converges and its sum is 1. If I put in x equals 1, I get 1 plus a third plus a ninth plus a 27th and so on. If I put in x equals 10, I get 1 plus 10 thirds plus 100 ninths plus 1,000 27ths and so on. I could also put in negative values, right? I could put in x equals negative pi, and then the terms would alternate signs because negative pi to a positive power is, to an even power is positive, and to a negative power is negative, an odd power is negative, excuse me. Right? So the point is, substituting in different values for x produces different series of numbers. And so putting in an x gives you a different value for each x, and so that's a function. I can call this power series a function of x, right? You substitute in different values of x and you get different results. The only thing, though, is some values of x produce a series that converges, but some values of x produce a series that diverges. In our three examples there, 0 and 1 for x give you convergent series. When x equals 1, we have a geometric series with ratio 1/3, so it converges. But x equals 10 gives us a geometric series with ratio 10/3, which is bigger than 1, so that diverges. All right, so some values of x give you a series that converges and has a value, a sum. Some values of x give you a divergent series, right? So this function sort of makes sense. It gives you a value only for the x values that produce a convergent series. That's okay. Lots of functions have some x values that don't make sense in them. So f of x is just going to make sense whenever you use an x that produces a convergent series. So that means that this function has domain only those x's that produce convergent series. Right. This function is called a power series. Technically, this is a power series centered at x equals 0. We'll see later in class a power series centered other places, but this just refers to we've got powers of x instead of powers of something else. This is a power series because it's got powers of x centered at x equals 0, and its domain, that is what inputs make sense, is just all the inputs that would produce a convergent series, all the x's for which the series converges. So let's figure that domain out. Here's our series again. We're calling it f of x, and I want to know the domain of this function f of x. To figure this out, we want to figure out what x's make this converge, and obviously there's infinitely many numbers I could try, so I can't just try them one by one and then each time let you know whether the series is convergent or divergent. We have to sort of have a general rule for which x's will work. So we're going to try the ratio test, and this is usually the first choice when you're trying to figure out the domain of a power series. The ratio test just seems to work the best. And that's because most power series either are things to the nth power or factorials. So the ratio test says I should compute this limit. As n approaches infinity, the absolute value of the n plus first term over the nth term. Well, the n plus first term is x to the n plus 1 over 3 to the n plus 1, and the nth term is x to the n over 3 to the n. And when you simplify this fraction, right, instead of dividing by the fraction on bottom, you multiply by its reciprocal. Lots of x's and lots of 3's cancel out, and what we've got is just the limit as n approaches infinity of x over 3, absolute value. Now notice that thing we're taking the limit of doesn't have any n's in it, so it doesn't matter that n is approaching infinity. It doesn't matter what n it is at all. It always is the same value, absolute value of x over 3. So this limit is just equal to the absolute value of x over 3. And what does that mean? Well, the ratio test says if you compute this limit, the series will converge absolutely if the limit is smaller than 1 and diverge if the limit is greater than 1. That means we have two possibilities. The series converges if this limit, absolute value of x over 3, is less than 1, which we can algebraically rearrange to the absolute value of x is smaller than 3, and that means x is between 3 and negative 3. And the series diverges if that limit is greater than 1, which we can then rearrange to the absolute value of x is greater than 3, and that means either x is bigger than 3 or x is negative and it's smaller than negative 3. Right? So that tells us what happens if x is anything except for 3 or negative 3, right? If x is in between 3 and negative 3, the series converges. If x is outside of that, the series diverges. What if it's exactly 3 or exactly negative 3? We have to do those cases separately, not using the ratio test, because the ratio test doesn't tell us anything if the limit is exactly equal to 1. So if x equals 3, we just put that right back in the original series. And what we get is 3 to the n over 3 to the n, and that's always 1. So we're just adding up 1 plus 1 plus 1 plus 1 plus 1 forever. That's a divergent series. One way to see it is it's geometric with ratio equal to 1. So it diverges. If x is equal to negative 3, we have negative 3 to the n over 3 to the n. That can be reduced to negative 1 to the power n. So this is a alternating series, right? If n equals 0, you get 1. If n equals 1, you get negative 1, and then 1, and then negative 1, and then 1. That's also geometric. Now the ratio is negative 1. It still diverges. So in both of these cases, the series diverges. Now, this is not generally what happens. Sometimes those specific values, they'll both cause a convergent series. Sometimes they'll both be divergent. Sometimes one will converge and one will diverge. So you have to check them each time. So what does this mean? If we look at our number line, anything outside of negative 3 to 3, including those precise numbers, negative 3 and 3, is an x value that makes the series diverge. That means those x values are not in the domain of the function, right? Those x values don't make sense in the function because the function is the series and they would diverge and not equal any value. On the other hand, if you pick x to be in between negative 3 and positive 3, the series converges, so it would have a specific sum, and so the function makes sense for those x values. So the domain of this power series is the interval from negative 3 to positive 3, not including negative 3 and not including positive 3. So we write it in this form with parentheses. That means don't include those points. That's interval notation. Some vocabulary associated with this: the interval of convergence is another name for the domain. That is the interval where those x values make the series converge. That's the domain of the function. Sometimes it's more convenient to talk about another thing called the radius of convergence. The radius of convergence is what you get if you measure from the middle of the domain, the middle of the interval of convergence, to the edge. So it's the distance from the center of the interval to the edge of the interval. Okay, so in this case, the interval of convergence is the open interval from negative 3 to positive 3. And the radius of convergence is 3, because if you write down the interval of convergence, you pick the point in the middle and measure all the way to the edge, you get 3. Video question to bring to class. Suppose that there's a power series and we've figured out its domain, and its domain is the interval from negative 3 to 7, including negative 3 but not including 7. What is its interval of convergence and what is its radius of convergence? Bring that to class. I will see you there and we'll look at lots more examples.